When New Year's comes around, everyone looks forward to fireworks. They sparkle, they pop, and most importantly, explode into an array of beautiful colors. Fireworks come in many shapes and sizes, from sparklers and firecrackers, even to colorful fountains. But little know the fantastic chemistry, as well as the history beside these small, colorful guys.
Legend has it, fireworks were originally conceived between 600 and 900 AD, when a Chinese scientist added a mixture of saltpeter, charcoal, sulfur, and other ingredients to unintentionally create a form of gunpowder. After the initial discovery, fireworks were implemented in many celebrations in Chinese cultures, such as the Chinese New Year's. Soon, fireworks expanded outwards, becoming a staple in many worldwide celebrations to commemorate the coming of a new year, remembering the birth of a nation, or even at the beginning of a baseball game.
Fireworks consist of an aerial shell, a bursting charge, firework stars, all surrounded by a paper outer shell. The aerial shell is filled with a large quantity of gunpowder in order for the firecracker to scatter its stars. Inside the aerial shell are the stars, balls of explosive chemical materials that combust after being launched. The stars are what gives the firework its color. When a firework explodes in the sky, the stars are launched and bursted, creating a fiery color that radiates from the center of the firework. The bursting charge of the firework is basically a string attached to a rod full of explosive black powder, which, when set ablaze, initiates the explosion of the aerial shell and stars.
A firework shell operates very much like a cannonball. After it has been lowered into a fiberglass mortar, the fuse is lit and the flame travels down the fuse and into a charge of black powder, which is contained on the outside of the shell right in here. When this charge is ignited, it simultaneously fires the shell from the mortar as well as igniting a time fuse, which is a delay between when the shell is fired and when it explodes in the air. The fuse that is ignited as the shell fires from the mortar is made specifically for this purpose. It burns in such a way that the flame travels through the core of the fuse without igniting the paper on the outside. This fuse does burn rather slowly, and for a shell of this size you only want a piece about this long. As you can see in this model, the fuse is extended to be directly in the center of the shell with a 1/4-inch cardboard tube. It is made so because if the ignition point were not directly in the center of the shell, it would burn unevenly and the stars would be thrown in a non-symmetrical break. In order to ensure that plenty of fire from the fuse leaves the end of the tube, the empty portions are filled with black powder-coated string, similar to the quick match fuse. Now once the black powder lift charge has fired the shell into the sky and this time fuse has burned all the way through into the center of the shell, it will ignite the break charge. The break charge is all of this salt and pepper colored material that you can see filling the center of the shell, as well as this middle ring right here. When the break charge is ignited, it simultaneously forces the shell to explode, as well as igniting many spheres of pyrotechnic composition. The black spheres, which are in 2 consecutive rings inside of this shell, are known as stars. They are what create the visual effect you see in the sky when a firework explodes. By varying the compositions that these stars are made of, they can be made to burn in any of the colors that you see in fireworks. In this particular shell, you can see that the stars have been shaped into 2 different rings. This is called an inner and an outer petal. The effect that this would present in the sky would be 1 sphere inside of another. In most shells, there is only 1 single petal, and so the inner ring of stars is disregarded. This smaller 3-inch shell would be a demonstration of a single petal.
Fireworks can vary in composition, but all have relatively the same chemical structure, a chemical compound consisting of gunpowder for the explosion, and another element often chosen for the color it glows when put in high temperatures, adding heat, which in turn creates the iconic firework explosion. Fireworks contain an oxidizing reaction, in which the fireworks are oxidized usually by the nitrates, the main component, in black powder.
While the most common oxidizer is potassium nitrate, it produces a duller color compared to the other oxidizers as it decomposes into potassium oxide, nitrogen gas, and oxygen gas, causing less vibrant color due to the oxygen bonding to potassium, compared to the strong oxidizers such as the chlorates, which produce a fuller color due to the release of oxygen atoms attached. Although it's not commonly used, any perchlorate has one of higher light intensities due to having 4 bonded oxygen atoms when applied with a catalyst. All 4 atoms break off, causing the reaction, which causes the intense lighting. When fireworks explode, they follow the pressure law known as Charles' law, which states as the temperature of enclosed gas increases, the volume increases, if the pressure is constant. Meaning that as the pressure created by the reaction of the gunpowder and heat combine, the fireworks will expand and gain pressure until the container holding the fireworks cannot hold the pressure and will explode, creating the boom that is associated with fireworks. Behind fireworks is as colorful and spectacular as a firework itself. A perfect combination of different chemistry principles is what allows a firework to behave as beautifully as it does. Whenever a firework show is being displayed, remember the amazing science that humans had to discover in order to create the beauties now known as fireworks.